Okay, starting the live stream. And we are starting the local recording. Alright, and we'll go. This is Virtual Christmas Summit 2021, sponsored by Octoscroller Studios. We're here in the room sponsored by Wired Watts. And this is Alan Hanson speaking on Hanson Electronics. So Alan, it's all yours. Go ahead.
Thank you. Hi, I'm Alan Hanson and welcome to my session of the 2021 Virtual Christmas Summit. I'd like to thank the organisers and who've organised the event, and also for inviting me to present my first ever presentation and first PowerPoint and scared shitless. I also like to thank those people who are currently watching and those who watch at a later date. Who's Hanson Electronics? That's me. Due to my love of Chrissy lights, I'm working on becoming a one-stop site for getting the computer automation of Chrissy lights all from one spot, as well as DC DMX controllers, pixel controllers, P5, P10 panel controllers, and power distribution boards that I design and make myself. I also stock pixels, pigtails, enclosures, mounting strips, all sorts of tools. Everything's sold through my site, and it's all ex-stock stuff rather than done as a pre-sale or a bulk buy. Some of the boards are sold via Wire Watts, who you might recognise the name. And in the UK, Panels R Us also stock some of the boards. I first started in the Chrissy lights in 2004. My first controller was just a simple chaser, not real exciting. I'm into Chrissy lights, obviously. Do lots of reading, writing, chop a bit of firewood. I spend way too much time focusing on the physical appearance of boards after they're functional. And my AAH nick is used on everything from the old Lightorama forums that existed way back, or the Aussie Lightorama page rather, on ACL, on Falcon Christmas, on X-Lights. Everything is AAH, which I assumed everyone said as AAH, but I've heard on Zoom people call me R, which kind of makes sense. I've been involved in electronics since 1989, where I started a TV station working in the maintenance department. That's where I sort of developed a kind of a focus on making boards easy to repair and physically tough. I started computer control in 2008 after seeing Wizards in Winter by Carson Williams. That absolutely blew my mind and was way above where I was looking at doing myself with a simple VU meter chip driving my lead chaser for my Xmas 2004 or 2005, whatever I had on my roof at the time. My site's been going since 2013. It's busy. I send stuff literally all over the world. Antarctica is the only continent I haven't sent stuff to, but I do live in hope that someone will want something down there. Around this time of year, I'm usually developing some new boards. The boards are made initially for my own uses. When I put up my display, I think, it'd be handy to have a board that'll do this. So I go and make it. Then after that, they go onto the market. My original board was 2013 maybe. It was the board on the left there, the Mega 60, or AAH Mega 60 is the full name, Mega 60 or M60. It did lots of stuff, which made it rather expensive to buy, so I've made it obsolete after losing money on the thing. Then I developed the 2811 DC boards because pixels were just becoming a thing back in 2013. There was J1 SAN devices and stelloscopes back then, so there wasn't much in the way of pixel options, but they were starting to become a big thing because they're cool if no one else had noticed. Then I got into a bit of power distribution stuff. The first board, there's the hex fuse, which is basically designed to fuse the three outputs that are common on most of the brick style power supplies. The Power 8 is my first mega tree, which I put up a few years ago. I kind of developed, or I saw that there was definitely a need for power injection boards. There's a few other ones around. Falcon Christmas had their board, which I can't think of the name of at the time. And because I sort of look at my own display, I figured that it'd be handy having a null pixel buffer, which I'll explain more way later in the presentation. Have one of them in there for going on to my next prop, which was a fair few meters away. So there's two 30 amp power inputs on it, out to four 7.5 amp outputs. Then last year, I think it was, might have been the year before, someone asked about a smaller version for a smaller prop. So Power 4 became a thing. It didn't have a null pixel buffer on it because they're not hard to put in if you need them. Then I added a few more power distribution boards. The P10 fuse is designed for mounting directly across the back of a P10 or P5 panel. The terminals are designed to suit the fork terminals are actually on the power cables. The PS Dist 1 and PS Dist 2 are mirror images of each other. They're designed for screwing directly to the terminals of the brick style power supplies. There's mounting holes. I've got no idea how to annotate images or anything like that, so I'll just talk about it. There's actually mounting holes there. The board's actually rigid enough that you can get away without mounting or putting standoffs anywhere. Then these things, which I'm not a fan of, because I'm strongly against 12-volt pixels. Couple of boards for 12-volt server power supplies. First one's a fused one, 8 outputs, 15 amp maximum, 80 amp total for the board, which is 960 watts or thereabouts, which covers a fair portion of all the server power supplies. PS Dist 3 is an unfused version of it, so to break out to go to something that fuses into it. DC dimmers. I still make lots of these things because, for a start, I like dumb lit lighting. I've still got lots of it myself. DMX36 Mark II replaces the DMX36 original one. Only difference really was with I added dip switches for setting the start address compared with the DMX36 had software setting start address. 4 30 amp inputs, even though it's got 10 amp fuses there. It's got 120 amps for the full board, which is way above anything else out there, and it's probably a lot more than most people will need. So you can do 5 volt, 12 volt, 24 volt, all on the same board if you want to. The DMX18 is its little brother. It's got software setting start address. It'll do up to 40 volts input, 5 volt to 40 volt input. They're pretty boring. Hardly anyone uses them, but they're good things. 211 DC 30 and its little brother, which is half of it, 211 DC 15. These were the second boards that I made, and they were made for adding control of dumb RGB, dumb incandescent, and relays, solenoids, etc. for in a pixel network. David Peace is actually doing a similar sort of thing now with his Pixel to Things boards. Data comes in on the right-hand side as standard ground data and positive, either 5 volts or 12 volts, even though it's actually tolerant of 24 volt pixels if you happen to have any of them. That convert the 211 DC30 converts or receives that as 10 pixels worth of data and converts it to the DC signal for the dumb lights or whatever's there. Then the data goes back out down the chain. So you can daisy chain as many as you want on those things. So DC30, you'd theoretically have up to 50 of them daisy chained on one output of a Falcon pixel controller board or any of the pixel controller boards that support them. That's just, I've got no idea how to annotate things, as I just said. Pixel DC outputs, top and bottom, pixel data in and out on the right, and the power input and the fuse on the left-hand side then. Special ones. These are special because someone in their wisdom decided that two-wire, two-channel LEDs were a good thing because they're really cheap to make. And they've got effectively every second pixel is every second LED has the polarity reverse. So you turn on the power one direction and half the LEDs turn on, reverse the power, and the other half turn on. If you're over here in Australia, Bunnings, Big W, all those sort of retail outlets, that's the LEDs that they've gone to selling. The DMX 218 is a DMX board for controlling those things. They've had them on the market for 5 years by the looks of it. They're becoming obsolete, but I wouldn't say obsolete. Very few people who are getting into computer control use them. They almost go straight to pixels these days. The 2811 DC 230 is a 30-channel board for doing up to 15 strings of them. Like the 2811 DC 30, it's got 30 channels, pixel data in on the right-hand side there, power in the bottom left-hand corner, and it'll do 15 strings, 30 channels of those things there. They were actually made for a guy in Vegas who wanted to set a world record for controlled channels and controlled number of LEDs. And because the two-channel LED strings were really cheap in comparison and easy to power, they're an option for him. And this thing here is a lot cheaper per channel to control than what a DMX board is. And you daisy chain a lot more of them on the one output. Controlling the two-wire LEDs is a bit of an issue. This is a custom model I created for my own display in X-Lights. I actually offset so what you can see there, I can't point it because it's a bit pointless. There's actually two rows, rows and columns, right? 2 rows of 8 icicles each there. And they're actually, I've drawn them offset horizontally and vertically from each other so that when the next light's effect gets put over it, they'll turn on one half prior to the other half. You can't do much with them as far as colour-wise. If you do, I'll go back to that slide there. If you do have the ones with multiple colours on them and want to match the colours up, it's just a matter of swapping the channel number. So if you plugged into channels 1 and 2 and the colours don't match 3 and 4, just swap the wires over on the ones that don't match. DMX 224 is a bigger version of the 218, and it'll eventually replace it. It's got dip switch selectable start address, extra 6 channels on it. It has a function which I've called classic, there's a switch for it up top right hand corner there, which basically runs the board as if it's a the classic multifunction transformer, multifunction controller that comes with the lights. So if it's got test mode on there, put test mode and it goes through some chases or whatever. Put classic mode on and nothing else is turned on, it will either run the slow fade, steady on, all of those modes that those god awful 2i 2-channel strings run. Beside the classic switch is one marked idle, which looks like DLE in that image. What that does is you have classic turned off for a start, and idle turned on. What that does is if you've got no data being sent to the board from whatever your source of DMX data is, it will default back to running the classic sequence that classic function that you've selected, whether it's a slow fade or whatever. That's basically designed so if you're just starting out, I've got no idea what that is. That just popped up on my screen. Oops. Got no idea what I'm doing. Go back there. The idle mode. If you've got no data there, it'll just default back to the idle mode. So if you've got a whole bunch of lights you bought for Christmas, plug them straight into this thing here, turn on idle mode, and you've got 12 channels or 12 outputs, 12 strings of lights which are automatically controlled from the same thing. Then when you get computer control going, you can just send some data to it and you're up and going. Next slide. The Octoscroller. Maybe 2013, I can't remember when it was. No, it was later than that. It was a few years after that. The Octoscroller appeared. Can't think of his name. Travis Hummel, maybe. Tremel Hudson. He developed that for a job he was doing in the US somewhere, and it was an 8-sided panel. Someone jumped on board and decided that'd be a good thing for Chrissy lights to do. So there was a few bulk buys ran, and people were making their own Octoscroller boards. I sold it up some boards for a local guy, and looked at it and thought that's a fairly difficult design for novices to make because there's wires very close to the pads. So I created my own board. One day I'll make it. Then on Falcon Christmas, there was a bulk buy being organised by someone, I can't remember who it was. I said, I've got a new design, we can use that if you want. And in the discussion that happened after that, someone said, it'd be good if it had a real-time clock on it. And I thought, yep, I can squeeze a real-time clock under it. So underneath, which I'll show on the next slide, is a real-time clock. My latest version, which was a year or so ago, has extra features on top of the original Octoscroller. It's got the 2-pin terminals, which I've had, 2-pin power terminal, which I've had since day one. There's an input header at the top right-hand corner there for a jumper or something to act as a power switch. And you have an external switch if you want to turn the board on and off. Larger labels, which you'll see on the next slide as well. A few other things. Next slide. That shows on the right-hand side picture there. There's the real-time clock module. On the left-hand side picture, you can see a few things there. I don't know if my mouse comes up or not. The JP2, JP3 labels, which on the original design you couldn't actually see when you're using shrouded headers. Hopefully the next thing will pop up. There you go. So all those things circled are things that weren't on the original Octoscroller. Mine's an Octoscroller with an A, not BR, by the way. Fuse, power terminal, the power switch. Top right-hand side of the left-hand picture there's a map of where the 8 panels are, or 8 outputs are. So you can see that even when the IDC cables are plugged in, there's LEDs to indicate the power status and run status of the beagle bone. Hopefully there's, I'm about to have a look at a chat message. I don't know if that'll kill me or not. Yeah. Next slide, hopefully, which I've broken. Yeah. Next slide. Raspberry Pi version of the beagle bone, which is the RPi P10, plugs directly on top of a Pi 2, Pi 3, Pi 4. It controls three outputs, which are, I think currently it's about 12 P10 panels it can control. Pretty simple to set up. Nothing much to it. Lots of these are available both from Wide Watts and from Panels R Us in the UK. Now we're going to pixel controllers, which are, all my pixel controllers are Falcon controller controlled. The RPi 28D Plus, which is a later version of the RPi 28D. Two 2811 outputs, which you can't see the labels there, they're hidden behind fuses. Separate power for each of the three pixel outputs. 7.5 amp fuses supplied, because I vaguely recall, I think it's 10 amps that'll handle by just supply 7.5 amp fuses, because the cable coming out of the pixel controllers generally isn't capable for much more than 7.5 amps. I don't know if the next slide shows it or not. Yeah, there's a real-time clock module underneath it. Top right-hand corner, there's an external input which you can use for triggering an effect, triggering a shutdown script, do whatever you want with it. If you're really creative, you can actually use this as an output for different things, but I don't mention that anywhere. So underneath the regulator, the real-time clock module, the label there which says that the battery being used is a CR2032, which you can't transport lithium batteries by air, so they go out without batteries all the time. The user manual has got all these details in it. The board itself is capable of 1600 pixels, 1600 WS 2811 pixels for each of the two outputs at 20 frames per second. I've got no idea how much current that is. That's 80 amps maybe, I can't recall, which obviously you can't get from one output. So if you want to go more than 100, 150 pixels on an output, you need power injection, which that image on the right-hand side shows how you would potentially power inject downstream of the extra power in on the pixel run. The HE123 Mark II has a few extra features than the original one. I added an OLED display to it, some switches there for navigating through Falcon Player. Beagle bone black or green. I prefer the green myself because it's a bit cheaper and there's nothing it does or nothing it can't do that the black does. It plugs directly onto the headers there in the middle of the board. The board itself will do 16 outputs of 1600 pixels each at 20 frames per second or 800 at 40 frames per second. Real-time clock module if you want to use the thing standalone. To the left of the OLED display there is, first of all, there's a power switch for powering the thing down if you want to do it locally. Just press the button because you can't access the one that's on the Beagle. And right beside that, there's a header switch if you want to take an external switch out to the outside of a box or something like that. And there's two user inputs as well. 4 power inputs on the board to 16 7.5 amp outlets. I think they're 10 amp rated if you really had to, but with 30 amp, it works out as 4 lots of 7.5. The board gets configured as a RGB 123 48 cape or something, which I'll go into a bit later on. Top left and right side there's two outputs, or two headers for plugging in daughter boards, which are here. A couple of different options for the daughter boards. The HE123 TX, which is the top left-hand corner, sends 16 outputs of differential data out to the HE123 RXs, which each of those boards will receive four outputs worth of data. Being long range, it'll go up to a few hundred meters if you need to. No limitation on the number of pixels. You can go, each one of those 16 outputs can have 1600 pixels at 20 frames per second, exactly the same as the main thing. The board doesn't get configured as differential or whatever in X lights. The HE123 RX can also be used with Falcon F48 if you need to as a dumb controller, and another board which I'll talk about in a sec. The other option on the next daughter board is a HE123 RJ, which basically just brings out the 16 outputs to a bit of Cat5 cable or via an RJ45 connector to some Cat5 cable for going out to HE123EX. So you'd use that if you wanted to go, say, a metre or so, or a yard for Americans and whoever else uses yards, up to about a yard away to extra power supplies and boards, because it gets very tight in there when you've got so many pigtails or leads hanging off the board. The final daughter board is the HE123 PX, which I make, but I don't recommend. Works fine, but having an extra 16 set of pigtails coming out over the top of an existing set is very, very, very crowded. It's got 4 power inputs to 16 power outputs. I'm actually going to revise this board and a few others later on to give more room inside enclosures. More details on that one day. Final board there, which I didn't mention, is the HE123 4T, which is a 4-channel differential transmitter. That can be used with the HE123 RJ to give you extra differential channels if you want to, but in the middle of the board there's a 5-way terminal which you can solder a 5-way terminal block on there if you really want to, and you can actually use this board as a differential, a 4-channel differential board from any standard pixel controller. Or when I'm testing, I should use a pixel tester for testing the long range stuff. And that'll go out to the HE123 RX, and would also go out to any other dumb differential receiver boards that anyone makes. X-Lite setup of the RPi 28D Plus. Currently, my Hanson controller, X controller file is a work in progress. I've had a bit of a play with it, and it just needs to talk to some gurus to get it sorted. So at the moment, you would set it up as the vendor, or to start, you add an Ethernet controller. I've called mine RPi 28D Plus because that's what the name of the board is, but you'd name Megatree or whatever suits. Add a vendor is FPP. Eventually it'll become Hanson Electronics. The model is a Pi hat, which works but doesn't cover all of what's on that board. I personally recommend using multicast until you've got everything going. Add some universes, and then save, and then you've got your controller set up. Create a prop, make a tree there, plonk the tree down, stretch it out, whatever. The number of strings on there, I've got it set as 2, which is actually the physical number of outputs on your board you're connecting to. With 800 strings, not 800 strings, 400 strings, 400 nodes per string. Then with 6 strands per string, I end up with a 12-strand tree. Down the bottom there, I've got it coming. The first output of it comes on port 1 of the RPi28D plus, which at the top of under the model thing, I don't know if this mouse appears or not. Up there it says it's a controller connection is WS2811 ports 1 and 2. So we go back onto the controller page and have a look at visualize. It says I've got 400 pixels on port 1, 400 pixels on port 2, and I've got nothing on the DMX port of the board. Setting up the HE123 under X lights. It also appears as a Falcon Player board. Added as a Ethernet controller again. Vendor is FPP again. The model is an RGB Cape 48, and the variant is revision F. If you pick one of the others, which I think C and D are also options, a couple of the outputs will be reversed. They'll come on at the wrong time, which will confuse you, and hopefully you'll just reach out and contact me and I'll say, no, it should be an F. Now, eventually these will all be off the Hanson Electronics vendor, but until they are, it's the way you do it. 32 universes gives you a couple of universes per output. Setting up a tree again. I've configured that as a 16-strand tree, 50 nodes per strand, so it's an 800 node tree, and the port starts at port 1, which indicates on the top there that the controller connections are WS2811 and ports 1 to 16. Looking on, I don't know, so on that image there, no, there's other stuff there, which it's all kind of in the manual. I've got some videos as well. The visualizer screen shows that there's 50 pixels on each of the 16 ports. If you kept on scrolling down to the bottom, it shows nothing on the other 48 ports. None of the 48 ports get configured as being differential or long range or whatever the options are, because that's all external to the signal that comes from the Beagle. That's about that. Multifunction controller. Lawrence Drive Lights down in Tasmania asked about adding some user input to a panel controller for, I think it's a donation sign or something like that. So I developed the RPi MFC, which has a bit of everything. Obvious thing is got no LED display on it. Some navigation headers there, which can go to the external switches for navigating within Falcon Player. At the top left there is 3 user inputs, which can be used for triggering scripts. There's one WS2811 output, so you can do up to 1600 pixels on the board, and one panel output, so you can do theoretically up to 12 P10 panels on it. On the underside of the board, there's a real-time clock. So in theory, this could be used, it could run an entire show with a panel for a tune-to sign or donations or something, and a small mega tree, and it'll play all by itself theoretically. The user inputs can be used for for shutdown. You could have it triggering a script. So if you have on your donation box, it detects the money's been put in, or could pop a thank you message up on the P10 panel or whatever. That's about all for that thing there. The setup for that one there isn't very integrated with X-Flights, because it'll do panels and it'll do pixels, and it actually uses the second pixel output on Falcon Player. So at some stage, I hope to get some better integration with X-Flights with it. But at the moment, all you can work from is the user manual and some screenshots and other stuff that I've got on the website. Accessories and tools. The pixel meter. On one of the Facebook pages, someone had a couple of tools, which was a meter for measuring the voltage of the pixel power lines. So I created this. It's got a pixel on there. It's just got a pixel node on there, which basically shows what the next pixel after that point should be doing. And there's a switch to switch in and out a null pixel buffer in and out of the circuit. The meter itself will run down to, I think, 3.2, 3.4 volts or something like that. So if the meter's reading something, the 5-volt nodes should be doing something. The pixel node on there can handle anything from 3 volts up to 24 volts. So there's no need to change meters depending on whether you're using 5 volts or 12 volt pixels. And again, you can use it for 24 volt pixels if you happen to have some of those fairground ones, or whatever they're called, with a whole bunch of LEDs in them. That's about all that board does. The null pixel buffer, that's been talked about. Someone else at the expo was talking about them as well. These are the ones I make. Pixels are theoretically meant to be able to go 11 meters from pixel to pixel, according to the WS211 spec it is anyway. In reality, it tends to go a lot less than that. 3 meters is good, 5 meters is really good. The distance from your pixel controller to your pixels can go from 3 meters to 20 meters, depending on the brand and model of all those things. So in the past, it used to be this dumb thing that if you couldn't get the data reliably from your controller to your first pixel, you'd stick a normal pixel in there, configure it as a null pixel, which basically means it does nothing, and then if necessary, add multiple ones to get it out as far as your first pixel. The same as if you're going from prop to prop, and it was further than you could reliably get the data. You'd put a standard pixel in the middle, and it wouldn't care. The data would get passed through that, but you'd actually have to configure that as a null pixel either in your pixel controller or in X-Flights or whatever your sequencer of choice is. So I've got those two different models of null pixel buffers there. They're totally transparent to the data. You don't need to configure anything. Just solder up the 3 pixel wires to there, your 0 volts. Oh, not 0 volt because there's an O there. Your negative, your positive, and your data via the in and the out things there. So you basically chop the wires, solder that in between. It doesn't care. It's tolerant of 5 volts to 24 volts. Doesn't care what voltage goes through the thing. And you can have as many as you need, but you probably never need more than one. I've tested to 33 meters, which is about 100 feet, before I ran out of cable, and I still had reliable signal. Felix at Scotland, who's also Ben Brown on ACL and a few other places, he tested some when he was making the the potted versions for me. He went to 50 meters before he ran out of cable, running a whole bunch of 12-volt leads at the end of it, and there was virtually no voltage at the end of the thing because there was just a very, very dull pastely pixels right at the far end, but the data was still good at 50 meters. So the bottom one is the ready to go version, which I make in a few different pigtail formats, both the Raywu 13.5mm and X-Connect plugs on them, and they can just literally plug in wherever you're losing signal and you happen to have a join, so just plug that in. On this, back on the pixel meter again, that Null pixel buffer you can switch in and out, and that's basically you can plug it in to see if you need more reliable data. So you just switching on and off, you can actually see if you've got issues downstream that where you need to bump the signal up for. And if you do, you just put a null pixel buffer, one of the PCB versions, or one of the ready to go versions. That's about it. Any questions? I've got no idea if anyone's asking questions. Is anyone listening? Oh. Oh no, I can't hear that, sorry.
No, I don't have any questions. I learned a lot from your products. I appreciate what you did. Thank you.
No problems at all. Share thing here. Don't know what this is going to do to me. Don't know if it's a good thing or not.